answers that for you guys so you can check your work. You can tell me what you need to see. And I always want to write these like as italicized, but I don't. Okay. So you're absolutely on the right track with, I think F is probably the most challenging problem here. You're on the right track if you kind of pulled this out and did that math separately. What I did there was found the magnitude first and then just multiplied by 1 over the magnitude. So if you haven't gotten a chance to try that one, go ahead and try it. And you can follow the negative u minus b is right here from the problem before, right? That guy to start. So the magnitude there square root of -1 squared plus negative or positive 7 squared. I saw some square root of 50s as I was coming around. And then how would we break down square root of 50? 5 radical 2, absolutely. So 25 and 2, so 5 radical 2. So instead of trying to take this vector and like dividing each piece, how I like to write it instead is kind of 1 over 5 radical 2 times -1I plus 7j. And then multiply through and rationalize, which is probably, the rationalizing part is probably the most labor-intensive part of the problem. So -1 over 5 radical 2 I plus 7 over 5 radical 2 j. And I left myself a gap in there so I could multiply by radical 2 over radical 2 to rationalize it. Try to keep that in there. So negative radical 2 over, this is your denominator here ends up as 5 times 2, right? Your radical 2 doesn't go away. You're doing radical 2 times radical 2, which is 2. So 5 times 2 is 10. And you have your I there. And then 7 radical 2 over, again, 5 times 2 is 10. The thing I really like about vectors is the math that we do with them is like addition, subtraction, multiplying by a scalar. All of it works the way, like pretty intuitively. Combine your like terms, distribute, works really easy. Okay, so a lot of textbooks put vectors with polar coordinates. And it's because they're both trig applications. And it's also because a lot of the things look very similar. You may have recognized from like 2 slides ago, one of our unit vectors was radical 2 over 2, negative radical 2 over 2. And that you should have been like, oh, a unit circle is everywhere, right? And if we are given just an angle and a magnitude, we can make a vector out of that using this. Our vector is going to be the magnitude times cosine of theta, sine of theta. And you can do that in component form, And you can do that in the I and J form as well. This is probably the 3 points on the quiz every year that is the most frustrating for me to be -3, because it is so like magnitude, cosine theta, sine theta. Put it on your equation sheet. No. So put a star or highlight that little bad boy as well. Magnitude, cosine theta, sine theta, if you are given a magnitude and an angle. So how about this? Given magnitude and angle. Make it back. And you can, with those angles in there, you can then find, if it's a unit circle angle, I would expect you to find the exact value and distribute that magnitude in. Let's bust through these, and then we're done for the day. So if our magnitude is 5 and our angle is 0, my first step is going to be this. 5 cosine of 0, sine of 0. This is degrees, although 0 radians is the same. This is the unit where degrees happen to us. I really feel like degrees are something that like happens to us. We get so good at radians. What is cosine of 0? 1. And sine of 0? And then you can multiply your 5. I'm going to write it both ways just so we practice component form and the IJ form. All right. Magnitude of 8, theta is 30 degrees. Put your unit circle values in there. I love that I just heard like 5 people be like, I love it. So cosine at 30 degrees or pi over 6 is radical 3 over 2. Sine is 1/2. Multiply your 8 in. All right, try the next two. 120 hurts me, but not as much as 315 does. 315 hurts me the most because it's so far around. So for C, you should get -2 as your horizontal component and 2 radical 3 as your vertical component. Or if you're writing it with I's and J's, it would be -2I plus 2 radical 3J. D, what are sine and cosine of 315? Yeah, it's a pi over 4. It's the pi over 4 in the fourth quadrant. So cosine is positive and sine is negative in quadrant 4. And then just multiply across. So you're going to have 7 radical 2 over 4 times 2 is 8 is your horizontal component. And your vertical component, negative 7 radical 2 over 8. Or 7 radical 2 over 8i minus 7 radical 2 over 8. Any ideas how we would find a vector that's in this state that has a different magnitude than we're given? So this guy does not have a magnitude of 7. How do we, any ideas how we would bump that up to a magnitude of 7? So the first thing we are going to have to do in order to take this vector and make it into a vector with a magnitude of 7 is shrink it down to a magnitude of 1. So here, if we're going to find, well, the first thing we're going to do is find the unit vector. And then you'll multiply it by 7. So your new magnitude times your unit vector. Trying to put all the math you learned today all together. So let's see if we can squeeze this one into the period. So the way that we find the unit vector is we do 1 over our magnitude times our original vector. And our vector here is 2, 1. So 2 squared plus 1 squared, 4, 5, square root of 5. So we're going to multiply our original vector by 1 over the magnitude. And you can rationalize it any point that you want. So if you don't want to rationalize right now, that's fine. 2 over radical 5. 1 over radical 5. There's your unit vector. So we shrunk it down to 1 from a magnitude of 5, or square root of 5. And now we'll multiply it by 7. And you guys can multiply that and rationalize it